Let's go on to the new topic of indices. We want to cover indices and logarithms, and we start with the indices. Right. Indices means powers or index in a singular form. It's powers in a plural or power, which means index in a singular form. Right. Let's have a to the x to the power a. In x to the power a, x is the base and a is the index or the power. Right. I would like you to understand this table. I can't talk about it much, but you should understand it because it will be very useful in indices. You must understand perfect squares and perfect cubes onwards, giving numbers powers and simplifying them. Right, what do they give you? You must all understand this. So you must practice to know this. You must be in a mood that whenever you see a number, you can tell whether it is a square, a cube, or whatever type of a number it is. You must be used to the numbers. The number system. You must understand the number. However, let's go on to the laws of indices. Right, we are going to cover just a little today, just to introduce you, starting with the information, the concept that you learned at Form 2 level. Right. Let's consider the laws of indices. Right, we should know that a law is a generalization that results from an experience that comes to the same result. An experience that comes to the same result an excessive number of times. Right? The common truth in indices is called the laws of indices. Right? We want to consider the laws of indices, and we consider the laws of indices representing the numbers by x, where x is any number except for 0. Where x is any number except for 0. We can say that, right, law number 1, these are the common laws of indices. Right, number 1, we say x to the power 0, which means any number to the power 0 is equal to 1. Number 2, x to the power 1 is equal to x, meaning any number to the power 1 does not change, it remains as it is. Right, 3, x to the power minus a is equal to 1 over x to the power a. Right, this means that any number to a negative power is equal to 1 over that number to the power that power without the negative sign. I repeat, any number to a negative power is equal to 1 over that number to the power that power without the negative sign. Right, number 4, x to the power a in bracket power b is equal to x to the power ab. Right, we are talking of when one power is inside the brackets and another power is outside the brackets, you multiply the powers to get a single power. Right, x to the power a, number 5, x to the power a times x to the power b is equal to x to the power a plus b, which means multiplying numbers of the same base. When multiplying numbers of the same base, you just take the base ones and you add the powers. Right, x to the power a divided by x to the power b is equal to x to the power a minus b. This means dividing numbers of the same base, you just take, when dividing numbers of the same base, you just take the base ones and subtract the powers. Right, number 7, x to the power a over b is equal to the b root of x all to the power a, which means when a number is raised to a fractional power, you just take the denominator of the power to be the root and the numerator of the power to remain the what? The power. Right, number 8, xy to the power a is equal to x to the power a, y to the power a, which means when a power is outside the brackets of multiplying or dividing terms, that power affects both terms or the terms inside the brackets. Right, x over y in bracket to the power minus a is equal to y over x to the power a. That's when a fraction is raised to a negative power, you just invert the base so that the power becomes positive.